Welcome everyone to, first of all, Vega's first Twitch TV streaming. And second of all, this is a deep dive into the Vega ERC20 bridge with the bridge builder himself, Danny Holland, engineer at Vega Core,
Howdy, guys.
with many other talents as well. I'm just going to say sacrificial pancakes.
Yeah.
Maybe
we'll get there.
later.
We'll get there, maybe.
And Vega co-founder, that's the echo from the Twitch, and Vega co-founder and lead protocol designer Barney Mannerings. So they're gonna have a bit of an interview style between them, talk about the bridge, dig into some questions, and for anyone listening or twitching, is that what you said? Please write comments either there on Twitter or in the comments here in the webinar, and I will moderate them after they have talked. Yeah, and with that, I'm going to give it over to you guys. Thank you.
Awesome, thank you, Christina. Welcome everyone. As Christina said, we're going to try and do a little bit of a tour of the Vega Ethereum bridge, talk about what that is, why it's kind of really exciting and cool, and maybe different to some of the other things out there, and why Vega needs it as well. So we'll cover all of that stuff over the course of this sort of session. As Christina said, we'll do it in kind of sort of an interview format. We'll maybe do a little bit of a live demo of how the bridge works, depositing collateral as well, just to kind of give you guys a bit of a feel for what we've built and how cool it is. And then we'll open things up as well and give you the opportunity to ask some questions as we go through. So, I thought it would be nice actually if we start off by giving a little bit of background to ourselves, just 20 sort of 30 seconds. So, for me, I'm, as Christina said, one of the co-founders of Vega project. I sort of came up with a bunch of the kind of original sort of concepts and ideas for how the protocol would work and how we could improve on what was out there in terms of decentralized derivatives protocols and decentralized trading generally. Along with the kind of the team that we built quickly at the beginning of 2018, we kind of pulled together this team and designed Vega and solved a whole bunch of super difficult problems. And I don't want to take too much credit here. Like, I came up with a lot of the ideas for the core protocol, but actually all the problems that I thought we would solve with the protocol, I kind of then said to the team, like, I think this is a doable thing, but actually, we've now got to go and actually do the hard work of working out if it really is and how to do that. And one of those things was the bridge, and there's a bunch of other things which we'll probably do similar sessions like this on around around everything from risk to front running and other things as well. So that's where Danny comes in on the bridge side, for instance, which we're going to talk about today. So that's really me. I'm super into the tech of this stuff. I love sort of decentralization, privacy, crypto in terms of cryptography, not just cryptocurrencies. And I'm sort of super interested in all of this stuff and the sort of the superpowers it can give people, and the ways that it can change how we all do stuff. And that's really what keeps me here. So yeah, that's a little bit on me. Danny, if you want to do 20 seconds on you, and then we can get started on the bridge.
Sure. I'm Danny. I've been a smart contract developer since 2017, just before the first crypto winter. And I say first because there's going to be more. If anyone here thinks there's not, have fun. That'll be fun. I rode out the wave. I've launched tokens. I play with smart contracts. I like weird mechanisms. And that's kind of what brought me to Vega. I mean, doing this bridge is so weird. It's so kind of out of the left field. It's very different from just a standard token or a DeFi thing or whatever. So doing this bridge, it has been just really awesome, and I've really enjoyed doing that here at Vega. I'm interested in everything. I'm just a nerd basically, and again, why I get along so well with this particular team. Barney's a nerd, Klaus is a nerd, Pete's a nerd. We're all nerds. We're all nerds. That's it.
Awesome, thanks, Danny. So yeah, I guess to start at the beginning, when we designed Vega, one of the things we worked out was like we really love Ethereum, and actually, ERC20 was at the time and still is the place where people issue new assets and tokens. Stable coins are going to be super important part of the ecosystem, tokens for other projects. And so we kind of figured, that Ethereum was the first stop for what we need to do with Vega. But we also realized that there are lots of properties that Ethereum has that makes it hard to do, complex product trading and derivatives and fairness and all the other things we wanted. So we got to build our own network, and even the kind of layer twos that are being invented that are very general purpose, like the optimistic rollups and things, they have all these different properties, like you have to wait a week for withdrawals because someone can present a fraud proof, or they only allow massive performance improvements over certain types of operation that can be kind of thought of in a certain specific way through snarks or whatever else, or they have huge performance impacts. So everything has trade-offs, and we kind of figured there's a lot of money in trading in derivatives, and if this wins, that's going to support its own tech. So rather than try and shoehorn it into a general purpose thing, let's go build the best network and the best possible protocol for trading derivatives. But we still like Ethereum, we still like all the other protocols on Ethereum, we still like ERC20. So we needed to solve that problem in a way that didn't kind of shut us out of the ecosystem. And that's kind of where the bridge comes in, I guess. So maybe, Danny, we can start with a simple question. At the very high level, what is the ERC20 bridge?
That's actually a good intro. Due to the fact that we're a very finely tuned network just for trading, we don't have any internal assets. We don't have, we're not launching tokens on Vega yet. We're not doing anything like that. So all of our assets have to come from somewhere else. They have to come from some other blockchain. And so we decided to start with the ERC20 spec because the vast majority of assets in the crypto space either are ERC20 native or have been wrapped as ERC20s. So what we did, what I wrote specifically, was I created a series of smart contracts that will allow you to lock up any ERC20 asset into this bridge, and the Vega network itself will recognize that the deposit happened and credit you on Vega. So this is fully non-custodial. It's not in any way, shape, or form controlled by any individual. It's controlled by the network as a whole. We'll get more into that, but high level, it's just a way to get assets from Ethereum into Vega. Yeah.
Awesome. Yeah, that's a great summary and really kind of explains the need for this and what it does. So obviously we have the Vega network, and for those who don't know, Vega is a blockchain based on the Tendermint consensus algorithm that's highly optimized for trading. So instead of running EVM code or WASM code, although it might do some of those sorts of things later when we have a sort of product language, instead of running code directly like that, it actually has a sort of trading engine which covers a lot of the key parts of trading and risk management and super optimizes them. So we've got that Vega network, but other than the Vega network, what are the sort of key components of the kind of the bridge system that allows us to connect Ethereum to Vega?
Right. So there are three core smart contracts that we use. The first one being multi-signature control, which is it's a scheme that allows the let's see how to put this. It allows the Vega network to issue commands as a signed bundle that someone can then take and run smart contract functions on. So this is a security mechanism that allows for multi-signature in a way that Ethereum doesn't natively support. That's the key component for the security. But then there's the asset logic, or sorry, the ERC20 bridge logic, and then there's the ERC20 asset pool. The bridge logic is exactly what it sounds like. It's all the logic for deposits, withdrawals, setting thresholds, setting limits, things of this nature. And then the asset pool is where all of the funds get forwarded to. It is a super simplified, very stripped down smart contract that only has the bare minimum necessary to function as a repository for all the assets. The reason we split them into an asset pool and a bridge logic is that the bridge logic is complex, and we may find a flaw, we may find a bug, we may want to upgrade or add new features later. And breaking them out allows us to upgrade the logic without having to issue the movement of every single asset and every single bit of every single asset every time we need to make a change. So the asset pool, super simple, super easy to deal with, and we can just switch the logic as we need to. So those are the key components of the smart contracts. And then we've got a service running on each node called an event queue, which watches the Ethereum network for events and then propagates them, or more makes Vega aware that they exist, and then each Vega validator node can individually look at its copy of Ethereum and say, oh yeah, we are in fact, or we did in fact see that deposit happen. We did in fact see the event happen. So yeah, that's it.
Awesome. That makes a lot of sense, and that's a key sort of thing. So let's sort of go now into the kind of how do you make deposits and withdrawals. So if I'm a user and I wanted to use the bridge, like how would I make it? What's the sort of very high level flow for how to make a deposit withdrawal? And we can go and give this little demo of this in a second, but just to kind of at the top level, what is it that I need to do as a user of something like Vega?
For deposit, the first thing would be to acquire the asset you want, say DAI or wrapped Bitcoin or wrapped ETH or whatever ERC20 you want for whatever market you're trying to do. Then you run the approve function as you do for any other DeFi, you do for Uniswap, you do for anything else. You approve the bridge to spend your funds, to move your funds, and then you just run the deposit function. As with most DeFi, as with most of these sort of things, we've put a UI on the front of it to abstract some of the specifics away. But at the end of the day, it's just, there's a couple parameters, pretty simple, pretty straightforward, and you just run the deposit. Once that happens, the event that's raised from the deposit is picked up by the Vega Network, and you're immediately credited. Oh, I guess the only other thing I forgot to mention is you will need a Vega public key. You will need a Vega, account to deposit into. That's it. We tried to keep it as easy as possible, basically.
Yeah, I was going to say, how does that compare? Like, if I was thinking, used to using things like Uniswap or others, like, is it much different or is it pretty similar?
It's pretty similar in how the end user would interact with it, but it's very different on the mechanisms and just the complexity of the function itself. So if you look at like running a function on Uniswap, there's a lot of parameters. There's a lot of data you have to put in. For this, there's very, very few. Try to keep it as little as possible, try to keep it as stripped down as possible so that if someone has to manually deposit or run a withdrawal or something like this directly in like my Ether wallet or something, they can just reach out and they can just do that rather than having to do a ton of calculations and all this insanity. So yeah.
Awesome. So let's take a break here and demonstrate to people just how this actually works in practice, because I think it's really nice to sort of turn the words into something real and take a different pace. So hopefully my screen sharing is going to work on this Zoom webinar and everyone can see it.
Are we going to have to do the DEF CON rules that if something messes up, you have to take a shot?
If someone can get a shot to me by drone or we'll see. Let's see. Yeah, if something messes up, I'll take a shot. But I'm so confident it won't. I'm not even going to go find a bot.
Oh wow! Okay, do it.
Let's see. I have confidence in this team. Let's have a look. So hopefully everyone can see Vega Console and it's large enough on screen for you all to see this. So this is running our testnet. Everything you're seeing here is totally decentralized. If I take a look at the little network tab, just as a thing, it's a bit ugly at the bottom here, but the key thing up here, we've got a kind of 800 millisecond block time. We've got 8 validator nodes running on our testnet right now. And we just reset this. It was actually running for, I think, like 5 weeks or something since the last reset and since the last upgrade to the testnet. But we've added some new cool features, and check out our blogs and discords and all those other places to find out about some of them. But what we're really interested in today is how to get some funds from the Ethereum Rockston network into this Vega testnet. So super cool that all these prices and all these updates are coming from the decentralized network, it still amazes me how much like a centralized exchange it actually all feels, despite the fact there's no servers. No servers were hurt in the making of this video. So let's take a look at my key here. This is my Vega key. So I'm actually cheating. I'm using the Vega wallet. We run a copy of the wallet server on a server, so I don't have to run it locally, but actually you can go onto GitHub and download the wallet and run it on your machine and connect it all in, and that's all open source, so you can get involved with that as well. But look, you can see my key here, and you can see the assets I've got. So let's take a look at this. I kind of want to trade on this Tesla market here. I kind of think I've got an opinion about what's going on, and this Tesla market actually trades in T Euro, which is our kind of, our testnet Euro stablecoin, and I don't have any of those. I've only got some BTC and DAI. I wish I had that many actual BTC.
Hey Barney, can I interrupt real quick? This is testnet bridge, right? I'm going to drop the link to the Etherscan into the chat so everyone can watch the transactions as you run them.
Awesome, great idea. That sounds really cool. We can go do that, and actually, I'll let you switch the screen sharing after we've done it. And you can go find my transaction on Etherscan, and then we can go see how that's actually all connected up in the Ethereum side. So yeah, I want to trade in this Tesla market, and I don't have any T Euros, and so let's go take a look at my key. I'd like to make a deposit here, so I'm going to go through Euro test, deposit, and withdraw. All right, cool. So let's make a deposit. So it's first going to hopefully attempt to connect. Come on. Yeah, it's not.
Yeah, Etherscan's going super slow right now, and I think they use Infura, so we might actually be having some network hiccups on the Ethereum side.
It's okay. There you go. So actually has worked. I've just reset my refresh my browser, and it's actually connected to MetaMask there, and you can see it's pulled in my balance. So when I look on MetaMask, you'll see that I'm connected to this testnet thing. So let's try and approve T Euro for deposits, the same as you would do on something like Uniswap or whatever. Does Vega want to send this? You can actually edit the permission if you want as well. This I think is quite a new feature here, which MetaMask are built in. So you can either say, yeah, I'm just going to approve the asset with an unlimited amount, or I can sort of set a spend limit. I'm pretty happy with the unlimited amount, so I'm just going to confirm that, and that's going to go through on the Ropsten network. So you'll probably be seeing, Danny's probably seeing, and anyone who's following along, probably seeing that transaction go through. And what we should see is, how slow is Ropsten looking, Danny?
It's pretty slow. I think I might actually have the wrong smart contract address for that, because the last deposit happened 2 days ago. So unless we've switched over to test a new smart contract, I think.
Well, let me paste this, because this has actually linked me. That approval's gone through. But let me just shove into the, where do I put it? Is there a chat or a Q&A chat?
There's a chat, yeah.
I put in the chat, panelists and attendees, this link. So I think that's the transaction that I made to do the approval. So you guys should be able to probably see that if that works. So now that I've done that, you can see I've got quite a lot of T Euros. So I probably don't want to deposit 100,000. So so this is the bit where I'm going to start interacting with the bridge. So I'm going to decide I just want to send 200 of these through. I'm going to click deposit. And Danny, while that's going through, so this is the contract interaction. This is the smart contract call we're making. While that's going through, do you want to maybe explain to everyone what's actually going on right here?
Did you click deposit?
Yeah, I clicked deposit.
Yep. Okay, so what that's doing is that's actually doing a transfer from taking your TDAI or whatever that you previously approved and moving it into the asset pool via the bridge. So the bridge actually runs the transfer from and forwards it directly to the asset pool. Once it's there, it will raise the event that says asset deposited, and then the event queue will propagate that to the Vega network. All the Vega nodes will individually validate that, and they will see that that event happened. And it looks like it was complete. Yep, that's it.
Is that the transaction? Is that the right one there?
Yep, that's the one. So since we have not published the source code for that yet, you're not going to be able to actually decode the input data because Etherscan doesn't have that event in its records. I would like to publish that, and we will publish that the second it's audited. But right now I'm not going to, for the simple fact that if there's a bug, I don't want someone taking this code, running with it, and then losing other people's money. I'm not willing to take that risk or put that out into the world. So after audit, everyone can have the code, and you'll be able to then look at the input data and basically decode everything, see all the events, and see all of the specific values that you've put in.
Awesome.
But you can actually manually go through the logs if you click on the logs tab. Yeah. You can actually go through there individually, and you can say, yep, there's my Ethereum address. Yep, there's my, on the topics up at the top, like 1 and 2, there's my Ethereum address, there's the bridge address, there's the whatever address, because as these events happen, it tracks. And that's what we use on the Vega side.
Yep, and I can see here, there's the amount I think that I deposited maybe. There's an approval.
With the 5 decimal places, of course, because we're using 5 decimal places on our test net.
Yep. So there you go. So
fully understanding 18 is standard.
That 18 will be coming soon. We've got a bit of an internal refactor to do to make sure we can't break anything with 18 in extreme scenarios. So we're using 5 at the moment. But you can see back on the test net, that's all there was to it. The deposit was successful, and now I've got those €2 in the account. So the thing I wanted to kind of say here is that there's a big misconception that these sort of bridging assets and wrapping assets and stuff has to be this clunky process with lots of steps and lots of things, and really makes things feel separate and gross to use. We have, I think, done a really decent job of designing that all out of the way with the architecture of the bridge, and actually we've been able to get that €2 in as if it's a native token, and really a really sort of top-end user experience. So really, really cool design I think we've got with the bridge there. And that was just a quick demo there on how it works before we sort of move on to the kind of next question really for you, Danny, about this stuff, which is like thinking about other kind of layer 2 and cross-chain solutions. Like how do you see the sort of ERC20 bridge comparing? What kind of trade-offs have we made? How do you just think it all sort of compares to other solutions out there?
So my understanding of most of the other bridge solutions, many of them at least, I haven't studied nearly enough to give you a full overview, but many of them have mechanisms that take the like cryptographic output, or say the Merkle tree, or some really convoluted complex output from a function on one chain, and use that directly as the input on the other chain at like the machine level, right? That's a lot of the bridges you see. That's a lot of the like it's very versatile, but in my opinion, passing around large chunks of data is very prone to attack. So what we went with instead is the CQRS pattern, which is Command Query Response Control, something I think is what it stands for, which is just one network does its thing, it raises events, and then the other network individually validates, yes, we saw this event. It does make it a little less versatile. Like we have to manually program new functionality. We have to add like new functionality, one function at a time, but there's no chance of having a random or increasingly small chance of having a random attack vector we didn't expect because someone injected some code somewhere. So that's basically the tack we're taking. I'm sure as we go along, we will find more better and more secure things, and we will build those in as we can. Yeah.
Awesome. And I guess if we wanted that flexibility, you could kind of create a transaction or a type of data transfer on that within that allow very flexible data. Like you could be sending JSON or Ethereum outputs or EVM bytecode or WASM or whatever you wanted across that bridge, and then obviously you have the risks of the flexibility, but you could build the flexibility if that was what you needed. So I guess then the next question is, obviously one of the key things about these kind of bridges is the security model, and one of the things I always think is really interesting about some of the decentralized solutions for wrapping assets, like is it Keep Network and things like that, where you kind of you've got your Bitcoin or whatever, and there's a whole other network of things that have to keep hold of your Bitcoin and then issue this other token. The problem is you got to secure that other network now, because otherwise someone can get your Bitcoin. And how do you pay for that? And because normally I don't want to have to pay to hold Bitcoin. That's kind of, they're in my wallet. And so you have this situation where something like, the Keep network, you've got to pay to secure that, then there's a cost, and how does that get paid? Because that network.
Yeah, how do you incentivize that network where all the network is doing is just holding your funds? Yeah, exactly.
Exactly. And with Vega, obviously, Vega's designed to do one thing, which is to trade. And Vega has very strong incentives for trading. And within that network, that is going to secure the funds on Vega. And because that secures the funds, it secures the wrapping process as well, which means that that's one area where we're simply not introducing an extra hop, an extra layer of security. If the funds are secure in the network, in the smart contracts, in the Vega system, then the wrapping of them from Ethereum across to the Vega network is also sort of secure by definition, because Vega doesn't really care where they are. It's just securing that amount of money, regardless of where it is. So that's one part. But I'd kind of be interested to understand, that was part of the kind of spec and design that we came up with all together. But what I'm also interested to understand is for the rest of it, for the smart contracts, for the the bits of the interconnects, the Vega network itself, like how does the security model actually work, and where are there what are the key points from the security perspective of this design?
Right. So as you mentioned, the core of the security is Vega's network itself. We've come up with incentives. We have an entire system built around keeping this network running as safely as possible, for as long as possible. All of that. That's entirely other topics. That's like, we need to have whole panels on just that, because that is super interesting. I love all the things that have gone through the security for Vega itself. That being said, that is the security of the smart contracts. That is the security of the bridge itself, because no function that touches funds at all, period, is outside of the control of either the user depositing the funds or of the Vega validators themselves. At no point is there a bottleneck, a centralized entity, or anything of that nature. The functions can only be run if the validators have signed the order saying, yes, it can be run, and that over the threshold number of those allows it to be run. Period. Which means that so long as Vega doesn't get compromised, the funds don't get compromised. And there's emergency situations where we can totally kill stuff. But yeah, basically, if in a fully decentralized way, long story, that's a whole nother thing. Yeah, the funds are as secure as Vega itself.
So you're saying effectively, if I trust the Ethereum network, which is where the smart contracts are and the funds are, so if I trust that Ethereum works and that my ERC20 assets were secure in my wallet in the first place, as long as the Vega smart contract's been audited and is also trustworthy, then the only other thing I have to trust is the Vega network and validators. And you're saying there's no weaknesses, no extra requirements. Like if I'm going to trust the validators to validate my trading and to validate everything else I do on Vega, and I'm already trusting the Ethereum network, then there's nothing else I need to trust for my funds to be safe and for this to work.
Yeah, all of this hinges on quantum computers not coming out in the next, year or so. But yeah, short of some weird attack on either ED 22519 or 25519 or the ECC that Ethereum uses, unless there's a vulnerability there, yeah, I can't see any injection point or weakness in that particular system. And I've put it to the team, and I've put it out there, and we have yet to come to a hiccup or a potential attack there. That's always open. That's always an open question. If anybody thinks they have an attack, they think they have a thing, A, try it, please try it, and B, let me know.
And as Danny said, all of the code will be open source for this. We're going to go through a round of audits and stuff, as Danny said, one, in case people want to reuse it and making sure that we actually kind of believe it works, but also, we're going to incorporate some thinking changes over the next few weeks to various bits of the system that might change it a little bit. So once we get to a kind of point where we are pretty sure this is the V1 kind of mainnet deployable contract, we're definitely going to be open sourcing this stuff. And you know, very, very keen for people, and probably bug bounties and stuff as well, for people to find out if they can find any issues with what we've built here and what we've designed. So yeah, very cool. So I think we covered a bunch of the sort of questions that I had on here about that. You know, I know that one of the things I know is that, you know, one of the sort of the features, I guess, of the design was this kind of modular and separated into a few smart contracts that you mentioned earlier. Can you kind of explain, like, you know, for those sort of three bits, I think there's like the multi-sig control, then there was like the asset pool, and then there was like the sort of bridge logic itself, I think. Is that right?
Yes.
Yeah, and can you explain what the reasoning behind sort of splitting those things up? Why did that make sense, and what are we sort of optimizing for with that sort of split?
Right. Well, earlier I mentioned that the asset pool is separated from the bridge logic in case something happened in the bridge logic, because doing all the individual transactions to move individual assets, A, it's risky, and B, it's expensive. So having a separate asset pool makes sense in that way. As for the multi-sig control, having that be an entire separate entity, that allows us to create new mechanisms that have nothing to do with the bridge itself, or nothing to do with asset management, such as oracles either consuming or putting back out there. I had a couple other specifics that I was going to try. Oh, yeah, the automated positions. You know, basically, it allows us to affect change on Ethereum from Vega in a very generic way, so long as the smart contracts are written to consume it. There was enough of a use case to reuse multi-signature control to break it out entirely from the rest of the system. You're on mute, Barney.
Sorry about that. The shortcut keys seem to stop working. Yeah. So, and the other part of that, I think that all makes a lot of sense, and I can see a bunch of uses for multi-sig control, and might even ask some more questions about one of my favorite pet use cases in a second. But then the other thing, the asset pool, as I understand it, that can actually, the network can effectively vote in a different bridge. Is that right? So, like, effectively, if we decided we needed to upgrade or change the bridge logic, then the validators on the Vega network could effectively kind of switch which bridge is controlling the asset pool, something like that?
Yeah, and so I know I'm kind of preempting this because I saw this pop up, the troll question of if you can update the bridge contract, isn't there centralized control of the bridge? Right. Same question. The answer is no. There is no centralized control over any of it, because any of the upgrades that need to happen, anyone from the community, not just me, it can be literally anyone, can make the changes, deploy the smart contract to Robston or Ethereum or, you know, whatever network we're on, propose it to governance, and go through the process of switching the contracts. That's the only way. There is, like, I don't automatically get to update the contracts. I don't automatically get to say, oh, well, my changes are important, so they must be put in there. Like, that's not something.
And that goes through governance on the Vega network, right? So
exactly. Oh, yes. Sorry.
Going through the Vega on-chain governance process, which is voted for by Vega token holders. Then once the validators on the Vega network agreed to that change, then they'd sign, and that's where multi-sig control comes in again, right? Because that multi-sig control contract is ultimately saying, I will do whatever the quorum of Vega validators will tell me to do, and nothing else. Like, I'm not taking orders from Danny or Barney or Christina. You know, even if they all wear bright yellow hoodies, I'm still not going to listen to them unless they've got the quorum of validators signing it. So, like, yeah, it's really important that we do that. Like, you know, there's absolutely no way, even in testnet, in fact, that we can exert centralized control over this stuff. We can, you know, it's really, really important that we never have that ability, and that it always belongs to the community.
I 100% agree with that. Actually, it's funny. One of the biggest, like, bottlenecks and hurdles that we have in deploying and testing all of these smart contracts and stuff internally is exactly that. Is like, the second I remove all the admin functions, the second I remove all the centralized helpers that I've added to make life of developing a little easier, the second I did that, all of a sudden we're in real world decentralized mode, and it was a pain, man. We're like, oh yeah, you forgot to do this obscure thing over here, and that's why it's not working. it's a pain, but it's awesome because we know that we're not in control. Because at the end of the day, I don't want you guys to trust me. I want no one to trust me. I want no one to trust Barney. I want no one to trust anyone on this team, because that's not what this is about. It's about like it should be objectively good. This is an objectively good protocol. It's not because of us. It's not us, basically.
Yeah, absolutely. And I think, I think that we take that hit up front. Like, okay, it's going to be harder. You don't get to just do centralized admin, but it means we're going to spend more time developing kick-ass tools so that we can actually simulate and test things that are decentralized governance, things that are controlled by this stuff. And so, over time, we're going to end up in a really good place for this, because it's sort of native. It's how we've done things. We didn't kind of start with this kind of crutch of, we can just press this button on the admin thing and it'll all be okay. We always sort of started with this decentralized vision for it, which I think is really cool. So now I'm going to get on to one of my favorite topics before moving. A couple of last things to talk about before we move on to sort of questions. But get to one of my favorite topics, which is I mentioned at the beginning that we really love the Ethereum ecosystem. A lot of the stuff we've done, we've been involved with and worked with, and friends with a lot of the sort of people and projects around there. And we really wanted to be able to not just sort of have Vega kind of sit off to the side, but actually have Vega participate. And one of my favorite potential use cases for Vega is this one, which is where I kind of go, I want to build a smart contract in Ethereum where you can send some ether, maybe it's ether, maybe a different asset, send some ether. The smart contract will go deposit that ether in Vega automatically, take out a certain size of position, maybe over collateralized or under collateralized or whatever you want to do. Take out a certain position, maybe in one thing, maybe in 100 markets, maybe change the positions, maybe keep them forever. Take out those positions, control them all from the smart contract with no human intervention. And then that smart contract can kind of issue some tokens. So it's kind of hey, this contract has an ERC20, and now that token does something. So it could be that token represents an investment in a fund, a DAO type fund, but it could also be like a stable coin. Hey, sent my ETH to the Vega network, I took out an ETH USD position, and now I've got something that's worth XUSD, regardless of what ETH does. And it's more efficient than doing it on chain on Ethereum, because Vega's got much more leverage and got the ability to manage that. But out of the back of it, I still just issue ERC20s, so I kind of got my stablecoin or whatever I was building. I think there's some really fun and cool use cases in that, and I'm super keen to see people do that in the community, because I think it'll be really fun.
And multi-signature control will allow for that, because the deposit part's easy, because all that has to happen is Vega has to be aware of the events and say, oh yeah, sure, we accept that event. But as far as the getting things propagated back out, that's where multi-sig control comes in. And yeah, I'd love to see that. Minor point that I'd like to bring up is when we do this, if I'm involved, I'm not doing an ERC20, I'm doing an 1155. The reason being, you only get one ERC20 per contract, which means we'd have to launch a new contract for each one of these. Whereas if it's an 1155, we can issue the crypto items, which are, you can have multiple tokens on one smart contract. So I'd do it that way just to save gas and whatnot, and really to push the 1155 into the forefront. Like I originally wanted to do an 1155 bridge as well, but nobody's doing 1155 assets. Like that's not a thing yet, but it needs to be to save gas.
And presumably, like the community could deploy a bunch of different contracts. Some of them could issue ERC20s, some would do 1155s, and everyone will get to interact across this. So, can you tell me a bit more? Like, how would multi-sig control let me build a smart contract in Ethereum and have it kind of take out positions on Vega and work with it? How would that work? What else would it do? What would we need to add to the bridge?
Well, as far as the bridge itself wouldn't be the one that's handling that. That would be the separate smart contract. The multi-sig control, all we'd have to do is write a smart contract that properly consumes the check signatures, and you're under multi-sig, you're under Vega's control. That's it. The second you say, this function that properly implements that feature is under control of that smart contract over there, you're done. That's it. That's as far as you have to go there. As far as how to open positions and all that stuff, we're going to have to specifically dig into all the features on that. Doesn't look too terrible, but one of the ones that I'm really excited about is actually feeding back things that happen on Vega back out to Ethereum as an oracle. Now, the way this is planned, since Vega doesn't have any assets of its own, Vega doesn't own any assets. There's no fund that we can tap into to pay gas fees. So in order to propagate stuff back out to Ethereum, we would do basically the Vega Network would issue a thing saying, here's our data set, and any interested party can take that signed data set and then run the function on Ethereum, which would then check against multi-signature control, say, yes, this is a legit data point, and then write it as the Oracle on chain. So that's a process that I think we can definitely do, and I think that'll be.
So in that case, I guess what the nodes on the Vega network kind of just signing a stream of events of stuff that might be interesting on Vega, and most of that stream just gets totally ignored because no one cared. But if your smart contract's interested in like the price of something at midday on the 25th of December, then you're going to go take that particular event from the validator, and anyone can shove that into the contract, and then use multi-sig control to validate that it's really a Vega event. I guess that's kind of cool. So does that mean that, if we make basically the entire event stream coming out of the validators get signed by the validators, does that effectively mean that theoretically you could build a contract and just go verify pretty much anything on multi-sig control that you want to?
There is nothing that would stop that from happening. I think that would in fact be a great idea. And in general, the multi-sig control allows the interested party to pay gas. Like across the board, always. You want to list a new asset, you're paying the gas. You want to add a new validator, you're paying the gas. If you want to do a withdrawal, you're paying the gas. Like I love that. It totally gets it off of our plate and allows for like a kind of freedom that we absolutely would not have had if we had to manage a pool of gas fees and stuff.
Absolutely, and then the good thing is there's always someone who has an interest, right? Like if no one cares enough, then it doesn't need to happen. Like if you want to withdraw your money, you care enough to pay the gas, and right. It's going to be the same for everything. Like if you're building something on Ethereum that needs the data from Vega, someone who's using that thing or someone who's building that thing is going to want that enough to go pay the gas. And so it's kind of a really nice, neat solution. And then probably just my final little sort of wrap up question before we open up to questions is, what about other blockchains? I've heard that Polkadot's pretty big right now. Everyone obviously loves BTC, and then obviously there's probably more than anything, there's just a constant stream of people who want to trade their Dogecoin on Vega. So tell us a bit about other blockchains and how this kind of approach can kind of be used, not just to make Vega Ethereum trading sort of protocol, but actually sort of cross-chain.
Yeah. So the interesting part about these other chains is none of them are Turing complete, or very few are Turing complete. So I can't just go and write Bitcoin smart contracts, right? I can't just go and say, I'm going to port this bridge over to Bitcoin. No, I've got to go through all this convoluted mess to get anything even approaching what we've done with the ERC20 bridge on Bitcoin. That being said, Bitcoin native is absolutely top of the list. I know we will immediately have access to wrapped Bitcoin on Ethereum as an ERC20 from day one, but getting it to native Bitcoin, I think will make the Bitcoin maxis a little happier, which that has benefit in and of itself. And then as you mentioned, Polkadot, I definitely want to get a bridge going with them. Maybe even as a partnership with someone over there would be awesome. Hint, hint, wink, wink to anybody who might be on the stream. And then, as you mentioned, Doge, man, Doge needs to happen. That is like fucking top of the list. I don't care. It has to happen. Added bonus to that is if we do make a Doge bridge, we automatically get Litecoin. Not that anyone cares about Litecoin, but we automatically get a Litecoin bridge. So there's a little synergy there that might justify us making that bridge soon.
Yeah, definitely. We were talking about Dogecoin the other day, and I was like, I might mind somebody saying, "Hey, you get some free Litecoin." Like, maybe I'll just burn those and just send them to the zero contract.
Yeah, gross.
Who needs it? So yeah, I mean that's really exciting, and I think as you said, it's kind of interesting not being able to have, obviously Polkadot's the outlier there because they do support sensible smart contracts, so it'll be much easier to build something like that. The kind of the older, more script-based, less Turing complete chains are going to be more of a challenge, but multi-sig works, and a lot of the similarity between giving the validators are kind of like multi-sig key holders. The problem is adding and removing them and giving them more features and functionality and stuff. But in general, this stuff is doable. There are different trade-offs in each case, and the UX might not be as nice with Bitcoin as it's going to be with something like Ethereum. But we know it can happen, and we're going to get there. So watch this space for that. And that's all the kind of questions I had about this. So thank you very much, Danny, for the detailed answers and showing us. And I'd love to sort of hand it over to everyone on the call and everyone out there on the other side of my screen to sort of let us know what your questions are. If there's anything you want to ask.
I'm scared. I guarantee there's going to be a bunch of trolls from our team, so I'm looking forward to this.
I'm I'm gonna start with a couple of questions that's come in throughout the chat. So first of all, what do you expect of how many Vega nodes will secure the network at launch and going forward? And is there a trade-off between the number of nodes and latency?
That is Barney answers that one. That's
I can answer that one. Yeah. So yeah, that's a really good question. There is a trade-off, absolutely, and the trade-off is particularly acute actually with Tendermint. So if one of the there are many great things about Tendermint which we like, both in terms of how it's designed, how it's built, how we can easily modify it to include things like our Wendy fairness stuff, how sort of mature it is relative to other alternatives, particularly at the time we started building. The architectural approach it uses makes it really easy to build Vega actually in a blockchain agnostic way, so we could even move away from Tendermint if we needed to, perhaps even to support more nodes. But one of the big downsides is, I don't know if you've ever seen the graph of the kind of scaling, like above, I think it's something like 64 nodes, things start to get a bit hairy. And even up to there, you've got a latency trade-off. So absolutely, there's a latency trade-off. We have some ideas and some work going on in our research team about how to fix that problem in a more sort of long-term way, how to adjust and improve on it, and whether that ends up happening through Tendermint or through moving to something else is still an open question for the long term. To start with, as you mentioned at launch, one of the things we haven't talked a lot about yet, but the way we sort of see Vega first existing as a mainnet is we think that the community is probably going to select some validators, a relatively small number of relatively what did you sort of call it, like sort of prominent validators, like people who kind of are doing what you would call proof of stake plus proof of reputation, where it's kind of like, yeah, I put the stake up and I could lose that, but also look how much stake I've got on like Polkadot and Cosmos and all these other networks, and Filecoin and whatever, and look how many people I'm relying on delegating to me for me to make my revenue. Because suddenly then your loss if you screw Vega over is not like, what's ever going on this new Vega network? It's like your entire reputation elsewhere. So your incentive really is actually to look after all the networks that you're on for the longer term. So we're gonna rely on that kind of thing early on in order to sort of bootstrap what's going on. But that allows us to probably get away with there being a network, or the network, really not us. It allows everyone to get away with there being a network that simply has perhaps fewer nodes. So I think the number probably the first time there's a mainnet, and it'll be like an alpha mainnet that exists, and it'll be like really kind of sort of halfway between a testnet and a mainnet. We're going to allow crazy things to happen. It might be short-lived, so we don't expect that chain to be around 5 years from now. We're probably going to nuke it a few times and replace it with an upgraded version with some cool new features and fixing the bugs. So it's going to be, these things are going to happen in a kind of early way as an alpha, for people who are really into this stuff to get involved early on. But I kind of think between 10 and 20 nodes is probably where it'll sit for that period. We're definitely looking to increase it. Certainly, the more the better. But one thing to think about in this, you've got to look at everything from a risk perspective. If you've got that reputation looking after those things, other issues like how quickly all the validators will run new code if a big bug is found are important as well. So no point having 2,000 validators if the main risk is that you find a bug in your early code, and coordinating enough of them to run the new code will mean that all the money gets siphoned out before. So there's always a bit of a trade-off with this, and everyone making those decisions as validators and as community members kind of has to weigh that up. So I think probably 10 to 20 is what's going to happen early on. That'll increase over time, over the first year or two. And, with the research that's going on now, by the time, you get to the limits of what Tendermint can support, either we'll be working with them or, whatever, to upgrade and improve on what Tendermint can do usefully, or we'll be thinking about some of the other networks out there. There's well, not other networks, other consensus layers. And to be clear, we're very, very unlikely to ever migrate Vega to be on another network. So Vega's not going to suddenly appear on Solana or Polkadot directly on some other chain, because it needs to be its own chain for a bunch of reasons, and including things like the fairness widget, including things like the security and the economic model. They all work very differently to general purpose blockchains. But what it might well become apparent is that some of the consensus algorithms and layers that exist out there are actually better suited, and we could upgrade to one of those, or end up improving Tendermint so that it works better. So that will improve over time, but I think probably 10 to 20 nodes early on. And yes, right now there is definitely quite a big correlation between latency and number of nodes, but there are a lot of things we can do to improve on that massively as we need to.
Thanks for that. If I like your question, I'm just gonna say that was efficient. More to Danny. Are assets only withdrawable to the address they were deposited from?
They were in the version, or they are in the version that is running right now, but the code going to audit and the code going into test right now is not. So you can now specify a target Ethereum address, and then anyone can run the withdrawal order to go to that Ethereum address. So yes, you could withdraw directly into an exchange or whatever. Now, we didn't originally have that in there for security reasons, safety reasons. I thought I had made a pretty good case for not doing it that way, that the person running the withdrawal should be the one receiving the funds. But we had some back and forth and decided that the potential for risk there, like an injection attack or someone like fat fingering the target address or something, was like slightly less of a risk than the not having that feature, not giving the ability to withdraw directly to an exchange or someone else's account or whatever.
Yeah, and one of the things that just give a bit of color on some of those discussions, like the downside is obviously like when you submit the withdrawal once it's done and signed, when you submit it to Ethereum, you sign it with your key, so you're proving you have that destination key under the first version, which is really safe because it means you definitely have control of that wallet. But on the downside, if you think about the way the bridge works, because now once the validators have signed this transaction, said, hey, cool, yeah, we can do with this withdrawal, there's like quite a long timeout period. I can't remember how long it's going to be, but there's quite a long time where that money is now locked up and going to be withdrawn, or you've got to wait for it to get back in your wallet. I think it's like a week or something. And so if you enter an address which you don't control, like an exchange address, that money is no longer accessible to you at all until it gets put back in your wallet at the end of that time period. But equally, people are really used to withdrawing to exchange addresses or withdrawing to other addresses. And the other one is cold
Even
storage.
though they're told not to.
Even though they're told
over
not to.
and over again, yeah.
They're used to that. And then the other one is cold storage, right? So if I want to actually store my winnings in cold storage where I don't actually have control of it, to have to take it out and then make another step is kind of annoying. Or a custodian, actually I don't control that wallet because my custodian service does, because I'm a big institution, and now I'm going to have to fiddle around with wallets. And actually, some people who start trading this stuff, they don't know much about wallets. They don't want to do it. They want to let someone else do it. And those people won't give them the private key or won't give them MetaMask, so for obvious reasons. So you kind of get to this situation where there's a bunch of use cases which make people jump through hoops or make it too hard. So we had a back and forth, and we kind of went, no, actually, you should be able to enter any destination, and you just got to get it right. And we can, we might warn you if you look in the Vega console or one of the, the UIs that we work on, like we might put warnings saying, hey, this isn't the address that you've connected MetaMask with. Is this what you meant? But we're going to let you do it.
Yeah, to follow up on that, the main concern that we had initially was someone, the man in the middle attack. Someone puts in the wrong address in there for you in the browser. Now, obviously, we have we've got all the standard web security, we've got all of that stuff, but that's just thinking from a super paranoid perspective. That's always a fear, but your point is that I think it would be too much of a burden to continue that, and yeah, it would potentially drive people away.
There are some unsolved things there, especially if you're doing large amounts of trading. And like to think of two different types of wallet approach. You've got the wallet app which you download, and then you've got the browser-based wallet. With the browser-based wallet, you actually don't want to do big transactions if you're worried about that, because someone can get your private key if they can get into if they're running code within your browser window. So like, using a browser-based wallet is going to have its downsides as well as upsides. Using a wallet which you download, a thing we could actually do in future is add an outside of the browser confirm. So basically, we could actually say, you're running this wallet, you've got to go to something that's hosted on the wallet service that you're running, or something that pops up on your desktop or whatever, that's not in the browser, that says you were using this wallet you downloaded to sign this transaction, and that's going to send funds here, and you can check it. So there's a few cool things we can do to kind of, allow you to check, hey, I didn't enter that address, that's not the one I wanted.
Are you writing? I bet you someone's writing that spec right now, or getting mad at you for coming up with new features on the fly.
Someone's probably thinking, what's he saying? We're never going to build this, and we may never build it, but maybe someone in the community will. Maybe we will. But there's certainly UX stuff there and security stuff, and we always want to balance like UX, security, all those things. And crypto has not yet figured out wallet UX in general. It's getting closer, but we're not quite there. So I think there's a bunch of different valid approaches, and we're going to need to be very responsive to that stuff.
So one of them is a suggestion: when withdrawing assets, do you see the opportunity need for automated time-delayed refund mechanism to withdrawal address? Apparently this was common to secure against phishing attacks.
Like an expiry on the withdrawal, we have that.
Oh, we do?
Yeah. Oh. Yep. Yeah, all withdrawals come with a built-in timer. I don't know what the timer is. I think it's a parameter that can be set by governance, so it could be anything. But yeah, the second that expiry is gone, you can no longer run the withdrawal at all. So we know for a fact that we can recredit that user internally.
Yep. So if you start the process and don't want to finish it, that will happen. Although once you start the process and the withdrawal is approved, if someone did maliciously want to make it happen, that signed bundle will exist in the blockchain because you already requested it. And so you got to be careful. Like if someone maliciously gets that process started, they can also maliciously finish it.
Right. Now, the fun thing about that, though, is since the target is baked into the request and only the owner of those funds on Vega can make the request in the first place, even if someone does maliciously run that command for you, like take that bundle and run it, you still get the funds. I mean, unless you thoroughly messed it up, whatever the target is where the funds go. So, I mean, it's not like someone can go, oh, well, I'll just put my address in here and I'll run it for you and I'll get the money. It will still go to the same target, but yeah.
Yeah, they've got to convince you to sign the request to the Vega Network with your wallet to say, send it to this evil guy. Like this guy in Nigeria who's my best friend and who is the king and is going to send me the money, but I got to send it to him first. Like, when you do that, when you get that email, do not put his Ethereum address in your withdrawal.
Okay. I'll try. And then I'm going to bring up a question we got on the forum, our Discord the other day, which is, how is the bridge going to work with optimism? I assume a new bridge would have to be built. Wondering if this is considered at some point.
Yeah. So any new tech that's coming down the line for Ethereum will that necessitates us writing new contracts. We will write new contracts for, or the community can take it up. Obviously, the joys of being open source, right? But for the most part, the first wave of Ethereum 2, so long as they make the ETH1 shard, will still be running on ETH1. We'll still be there. Everything will be there. We'll still be good. So we won't necessarily need to migrate to anything new, anything weird immediately. But I would like to in the long run, yes.
Yeah, and you've got some of these things like, if something's on a layer 2, like I think with, if something's on a layer 2 and it requires a lengthy process to get it between the mainnet and the layer 2, then you kind of got two options, right? You can either move it back to the Ethereum main shard and be where the Vega contract is and just do it and it's fine, or if it's going to take a really long time, like I think his optimism might be the one where it's an optimistic roll up and you have like a week to present a fraud proof, so you don't get your funds for a week. I can't remember. There's definitely one of those. I think that might be optimism. And if that's kind of really annoying and you don't want to do that, then there's the potential to build things on the layer 2s where actually you go, hey, there's actually a bridge to this layer 2. So as long as those funds are on that layer 2 right now and they can be locked up in the bridge contract there, you can build the same bridge. You can kind of, we can kind of pick and choose between the different approaches. Either you're moving things around on Ethereum or you're moving them around in Vega. Kind of be interesting to see if we could make it faster to move them stuff to Vega and then, withdraw it through the other bridge than it is to actually move it within Ethereum. I think that'd be kind of fun.
that would be really cool to see.
That's possible.
Well, my only question there would be if the like say wrapped Ethereum on one blockchain is wrapped Ethereum on the other. You know what I mean? Like, are they compatible? We've had this discussion before, but like, at what point are two assets on two chains different? Yeah. But
yeah, and that's going to be an interesting one. Like, we're going to have to work out how that all works. Like, is there a, is it possible to consider those two the same asset, or do you not? There's a bit of work to do there, but initially anything that can get to a sort of a bridge contract that's deployed on Ethereum, regardless if it starts on a layer 2 somewhere or a different proof of stake shard, as long as that can be moved around, then it's going to be easy. And then where that can't happen, we're going to potentially have to have other bridges. But things that support the EVM, we built the bridge, so it's really
and they do have to have events. I have seen there's a lot of things with the L2s that they go and they process and they do things and they raise events on the L2, but all they do on L1 on Ethereum is just update balances. So sometimes events are lost depending. So if that happens, our whole pattern gets messed up with that. So those might not be.
Presumably that, I mean, I guess you then want to go build like you'd have to listen to the L2 event, and then you'd have to validate the kind of the roll up or whatever, which again is like, it's not doable. I mean, it's the same as the event validation that we do now. It's just an extra validation potentially. So I guess. Right. All of these things are possible. Each individual solution will have slightly different trade-offs and decisions to make. But the thing to remember is on Ethereum, many contracts will stay on the main chain, and many of them are on the main chain, and many ERC20s are issued there. So like the incentive that Ethereum have to make sure that every single asset on Ethereum can make it to the main chain as an ERC20 and interact with those contracts, super high. So even if it's not the fastest way to do it, there's going to be a way to go back to the same place as all the rest of DeFi, and to go and move the assets to the Vega bridge. So even if it's not the best way, and even if we can improve speed and latency and stuff of doing those deposits in future, I'm pretty confident that for a very, very long time we're going to be okay with that, just for that reason.
Thank you. And then on somewhat of a similar note, would we see doing a bridge for colored coins on BTC?
Yeah, I don't see why not. I don't know. I'm not big on BTC in general. I'm kind of a F maxi because why not? But yeah, I don't see a reason why we wouldn't support colored coins the second we have the wider bridge, the native BTC bridge, because once we've conquered the scripting BS that comes along with Bitcoin, the colored coins are it should be an easy get. So I don't see a reason not to.
There's a few considerations here, and most of them have nothing to do with the tech. Like the first one is probably developer time. The second one is competing standards. So like I remember investing in things that were counterparty.co. Tokens launched using that on BTC, and then they all migrated to ETH. Because it was a handful. But then we've got our friends over at RSK, and this is a smart contract layer for Bitcoin, and you can have tokens going on that. So that's one approach, and there are other similar things. And so I think the first thing is like there's a bunch of things you could build, but it doesn't mean anyone would use them. So we're pretty certain people would use BTC because like everyone, well, nearly everyone, a lot of people hold BTC. Yep. A lot of people want to trade it. You could even have cross-chain spot trades that are completely decentralized with an order book on Vega. So even just getting your ETH from BTC would be kind of cool use case for this anyway. So BTC is obvious.
Bitcoin, ERC20 was an obvious get. The Polkadot maybe something like what is that? Not consensus. Was it Coinbase's layer or Consensus's layer? They have an L2. Like there's a bunch of those that make sense. And I don't know if there's any good colored coins out there that are are valuable
I was
enough
gonna say,
to
there's a
be
couple
their
of
own
things.
asset.
You've got to have the need to have you've got to have the demand so that someone's going to bother building and testing it and getting it audited and doing it. And then you've also got to convince the validators to deal with it, because the one other downside, if you like, of this stuff is that you've got to run each network. Like, if you want to run a bridge and you're a validator, you've got to have an ETH node and you've got to have a Vega node, and then you've got to have a BTC node. So, you know, the other thing we've got to make sure is that whatever it is that people are running is something that's useful. And so, you know, we've got to convince the community to write the code, test the code, and we've got to do it ourselves as a team, and we've got to convince the validators to run it, and the validators have to accept that. And it's, you know, it's not our decision. You know, someone in the community is probably going to be the best person to build colored coins. They might go do it, and the validators might go, no thanks, no one wants this. So, you know, a lot of this is probably the same as all the other governance proposals and changes and all the other stuff in open source, which is actually, you've got to convince this community and this decentralized network to actually run your code and to do the thing you want. And I think, you know, when we're thinking about that stuff, that's going to be the big challenge for new networks if there's not demonstrated demand, because people are probably not going to want to add like 16 servers around their Vega server when most of them are not contributing anything to trading or what's going on. So I think that's probably going to be in the long term, the bottleneck is going to be that decision making. And then the pragmatism there says, well, for some of those things, and you know, maybe colored coins actually, because we end up doing BTC, colored coins end up maybe actually coming on board natively. But then other networks, it might be like, actually, we're just going to be happy with a wrapped solution as an ERC20 or something.
Right. And at the end of the day, everybody wants their token into DeFi. So yeah, there are going to be wrapped versions of every single one of these. So yeah, that's a very good point on the tech. So that's the why not, Christina. When I said, you know, I don't see why not, that's the why not. Yeah.
Well, as we said, you know, BTC is happening, and if there's a standard or two that are really getting popular, yeah, I think.
Yeah, but I don't know if there are. Does anyone know of a good like what's an actually high market cap like colored coin? Like, is there any? I'm sure I'm gonna get lots of hate from that. I'm sure there's some big fans out there. And
watch out, the Bitcoin maxis are coming for you, especially now you show your true colors as a ETH maxi.
It's true. It's true.
I'm a Hixel maxi.
Yeah, well, I mean, aren't we all?
I mean, we there. Are there any more questions? If so, raise your voices or type your keyboards. If not, do you guys have any final? Actually, I'm also, I saw you answered this question in the chat, Danny, but I'm just gonna distribute it to our wider audience across channels about if we envision any infrastructure to help validators / governance to validate a new version of smart contract.
So the infrastructure that helps is just the governance itself. Honestly, basically we hope that there's enough interest and enough use, and there's enough people who actually care about the health of the network, that if someone presents an upgrade to the smart contract, that no one's going to vote yes until they have proof of an audit, you know, and this sort of thing. So I think the infrastructure is just the governance itself. I mean, I think that's how that is.
There's two aspects to the governance, right? One is the on-chain tech, which is like, how does this happen? A proposal is raised, it is voted for, what are the rules? And, you know, that stuff's kind of, you know, out there in the docs and will be explained more and more some of these sorts of sessions. And then the other bit is the community bit, which is like, you know, you go follow some of the really sort of, you know, the probably sort of, what's the word? Like the best in class, best practice sort of winners of this at the moment, people like Compound. You know, you see how they put on Uniswap. I think are probably doing okay, although I'm not sure. They seem to be, their approaches seem to be a bit more controversial, at least some of those things, but they seem to be quite communicative about some of them. But certainly Compound, I think, are doing really well. And you see how they put proposals out there. They've got some key community members, and you've got people like Gauntlet as well, who will go and comment. And so there's actually a process in the community, which is kind of community led, with community norms, with forums being the center of things, with people writing really considered posts. And that's a big part of it. Like, how do we know whether to press yes or no? That's not actually a technical question, it's a people question. And so how we do this in the community, how we talk about it, how you guys listening talk about it, how our you know, people who are token holders talk about it, how market makers and liquidity providers and traders talk about it. Like, that is going to be a big part of this, because actually a lot of the decision comes down to how the people come to a decision of what they want to do and whether or not they should click approve on or not.
Right. Well, we also I assume we're going to be doing the bounty program indefinitely. That would definitely be a good bounty to put up as new things come up. You know, someone go audit this proposal. Somebody go, you know, do this sort of thing. Because yeah, I think it's going to come down to community. We can only do so much, and anybody can only do so much when it comes to like technologically stopping or building infrastructure, or doing, you know, incentivizing.
Yeah, absolutely. And I think
it has to come down to people.
Bounties for sure. You know, we've got bounties now. Go check them out. You can see what we are looking to get done. That stuff's going to only increase over the coming months. But also, like, you know, bounties not just for doing the auditing itself, but like tools. Like, I always look at, you know, Wikipedia. Like, there are things that'll go and look for like badly spelled words or bad grammar or facts that are out of date in Wikipedia, and they're like bots that just run and find these issues and fix them. I kind of see that happening on Vega. Like, people make proposals and there's all these bots running, and they're, you know, tweeting or posting automatically to Discord or whatever, going, hey, new proposal, here's all the things it flags up on this bot instantly, like that we found. And there's some really kind of fun stuff that the community can build to help everyone answer those questions and automate some of it as well. So yeah, absolutely, bounties and grants for doing things like that will be around.
And on that note, all of these things you can find by joining our Discord, following us on Twitter, subscribing to our community update, being in our forums. If you're actually watching this, that means that you're in one of the channels and you will get all the updates. Do you guys have any final words? Final thoughts?
Check out the testnet. It's really fun. You can actually you can use the bridge. You can go use the faucet, get some assets, deposit them, see how easy and quick it is, see how much better it is than like turning your assets into something, getting them onto Solana, moving them around, getting a Solana weird wallet, getting them into that other decentralized exchange. Like, you can see how much better this is. So go give it a go.
Can we get a debate between you and someone from Solana? Because I'd love to hear that. You've talked a lot of crap and used their name numerous times. I'd love to see a one-on-one. That would be awesome.
Maybe that is the second thing for our new Twitch TV.
Oh, dude, yes.
I actually have nothing against Solana, really, but I think that the UX for getting stuff into Vega is better than the UX for getting stuff onto another chain and then into an exchange, because we do it in one step. So that was pretty cool.
About also using our testnet, if you want any help with anything there, we have a weekly testnet jam between 6 and 7 GMT time, where you can drop in at whatever time. You can also find the invite to that across all our channels.
I got one more item I'd like to mention, just to put this out to the universe. I would like to, we were talking about this earlier, I would like to create a Twitch Plays Vega. If anyone watching remembers Twitch Plays Pokemon, Barney and I, we've been bantering about this. The team has been bantering about this for a little bit now. We want to set up 2 opposing teams of traders, two chat streams, and do the spam chat trading crap like Twitch Plays Pokemon. So we want to do that. If anyone likes that idea, start harassing us about it, because I really want that to happen. So I could use some support from the community. That'd be great.
As soon as the teams are ready, we'll set up two Vega terminals and start trading on testnet. And on that note, I think we're probably good.
Yeah, I think this is perfect. Thank you so much, Danny and Barney. This was wonderful. And if anyone has any feedback or any questions or want anything, we are everywhere.
We're here.
Yeah. Okay, cool.
Thanks, Christina, for hosting us. That was awesome. Thanks, Barney, for the chat. As always, it was awesome.
Yeah, thank you, Danny, and thanks, Christina.
Thanks, guys.
So, yeah.